Welcome back, COBOL crowd, to chapter 5 of my course on COBOL. Today we are going to talk about handling files in COBOL. First I will introduce the general file operations that we can perform in COBOL, followed by a discussion of the exception handling mechanisms that COBOL offers, and then we're going to look into the three file organizations that are available in COBOL: the sequential files, relative files, and indexed files. And finally, I'll show you how you can have files with dynamic file names, so where the name of the file is determined at runtime. Let's start with the general file operations. We've worked a little bit with COBOL files before, and so you have already seen this, but how we do it in COBOL is that you have two file names. The one that we're mainly interested in is the so-called internal file name that is given to the file in the COBOL program. And yeah, this is something we could compare to a file handle or file descriptor that we would use in a C program. And say F is this internal file name. And to this internal file name, we associate a system file name, which I call S for now, using this statement here: select F, internal file name, assign to S, the system file name. And this is done in the file control paragraph in the input-output section of the environment division. Now, this is what it looks like in code. So environment division, input output, file control, and then we have this statement here: select internal file, assign to external file ... So as an example. In my examples here, since I'm using GnuCOBOL on a macOS machine, this system file name will simply be the actual file name in the operating system, the file that is really on my disk. However, in other situations, for example, if you're working on an IBM mainframe, then this system file name is not in general the actual name of a file on disk, but rather you have some intermediate file name that is assigned to an actual file on disk by the job control language. So you will have like a two-step association of your internal file to the actual file on disk. And this is because on a mainframe, for example, COBOL programs are run within a job. That's kind of a script that takes certain steps, that prepares the environment for the COBOL program by setting certain variables to connect the COBOL program to the data on the operating system. And one of these steps is to define this intermediate file name, the system file name, for some actual file on the disk or on a tape. And this system file name is then handed to the COBOL program. And I would assume that the idea behind that is historically to make COBOL programs more portable, because if you don't depend on particular names on the actual machine that you're running on, it's easier to just have the same program run on multiple machines and then just fix up your job control script for the individual machine on which your COBOL program runs. This select statement that we use to assign the internal to the system file has many options for different kinds of files and access modes. We will not discuss them right now, but I will just note that there are three file types in COBOL that we can use. First, the sequential files. So here, as the name suggests, the records in a file are accessed in a continuous manner, so one after another, and the only way we can access a particular record in that file is to start at the beginning and iterate through all the records in the file until we reach the one that we're actually looking for. The second type are the relative files. So here the records in the file are actually numbered sequentially as if they were contained in an array, beginning with index 1. And then you can use the number of the record, so its index, to access this record directly, and you do not have to iterate through all the previous records. And third, there are indexed files. They are a bit similar to the relative files, but here you don't use the position of the record in the file to address it, but instead you use some alphanumerical key that is part of the record that is saved in the file. And this key can be used to directly access a record without having to iterate through all the previous records, or even without having to know its position within the file. So this is like a dictionary data structure in a sense. For now, we will just note that these file types exist, and we will discuss them in the later sections of this video. First, I just want to discuss the file operations in general terms, so independent of the particular file types, so you get an idea of what we can do in COBOL, and then we will flesh out the methods for the individual file types later. The idea behind the file operations in COBOL is that they're performed in a per record mode. So when you read or write something to a file, then this will always be a full record of a certain predefined type for this particular file, and you will not read individual bytes or something like that. To do this, COBOL of course has to know what type of data it should read from a file or write to a file. So we have to declare the file data structure in the file section, which is contained in the data division. And yeah, we've already seen this before as well, but now we'll look into it in a bit more detail. So for this, we have this fd instruction, fdf, where f is our internal file name. And then followed by this declaration here is just the record, the data type that is to be stored in that file. And yeah, we define this data type in the usual manner. So here we have an example. First, we connect our internal file to the system file. So as I said, in my case, this will be just a concrete file name on the disk. And then in the data division file section, we have this data structure for our internal file. And yeah, here I just have some random examples. So I just call it data set, and I have two entries in this record, name and age. And yeah, as I said, COBOL reads files on a per record basis. So there's no provision for reading files in a per byte manner. So there are no file streams in COBOL. And the problem with that is that it can be difficult to read data from files that were not created by another COBOL program, because yeah, these COBOL records are not perfectly flexible. So usually they have to be of a fixed size, or at least if they are of variable size, you have to assign some maximum size for the variable parts of the data. So if you have a file with data in it that can be of arbitrary length, then that might be difficult to read from a COBOL program, because you do not have these file streams. So usually when you read data from COBOL, you would expect it to be data that was originally written by a COBOL program to begin with. Now it is possible to store different types of data in the same file. So you can assign multiple records to the same internal file in the fd statement. And to do this, you simply follow your fd statement by the different data types that could be written into it. So for example, here I have a file that I call contact file. So think of it as a file containing contact information. And here I have two different records. One is home address and the other one is email address. So maybe some people you would want to contact by mail, and other people you would want to contact by email. So depending on that, you could either save their street address or their email address. And you see these are not even of the same size. So it is possible to write different data structures to a file in COBOL that are not of the same size. Now, how would COBOL know which one of these records, which data type would be used when you're reading or writing from files? Well, this is determined by the particular use of the read and write statements, the file operations that we will discuss in a few moments. And they will, if you need to choose between one of these data structures, then you can explicitly choose which one to use. And before I show you an example of that, I first need to explain a few of the file operations in COBOL. If we know that the records we write to a file will not be all of the same size, so for example, if we use tables of variable length, or as we've just seen, we associate different data types to the same file, then we can actually declare this to COBOL by including this line here in the fd statement. So fd, internal file name, contains n1 to n2 characters. So here we're telling the file data structure that the size will be between n1 and n2 bytes. Of course, here n2 has to be larger than n1, otherwise this makes no sense. And yeah, the actual length of the record will then be determined by the content of the individual record when we perform a file operation. Another way to tell COBOL that we have data of variable length is in the fd statement, the clause varying in size from n1 to n2 depending on v. So again, n1 and n2 are the minimum and maximum size that our record could have when we write it to the file or read it from a file. And v in this case is a numerical variable that will be queried at every file operation for the length of the current record. So we would have to explicitly set this variable to tell COBOL when performing a file operation how large the record that we're currently processing would be. Now, before we can perform any read or write operations on a file, we have to open it. And this is done using the aptly named instruction open, which takes two parameters, so open m and f, where f, as before, is our internal file name, and m is one of the file operations input. So here, if we choose input, it is only possible to read existing data entries from the file, and the initial position to read from will be the first entry in the file. Or m could be output. In this case, it is only possible to write data entries to the file, again, initially beginning at the first entry. And if the file already contains data, then this will be overwritten unless we somehow reposition to where we want to write the data. How to do this we will see later on. Then there's the mode I/O. This allows reading and writing data entries, but there are some restrictions on how to use this. We will see that when we look at the particular file types. There's extend. In this case, it is only possible to write new data entries at the end of the file. And it is also possible to open multiple files at once in different access modes here by simply combining them in one open statement. And even though it's possible, it's maybe not the best idea to do it like this because it will probably make your code less readable. So I would recommend just using a single open statement for each file that you use. And when we're done working with the file, we have to close it, and for that we use the command close F. And this will ensure that all the pending file operations are concluded, so no data gets lost if we properly close our file. And also we have to close a file before performing a different file operation on it. So if we first want to write data from a file, we would have to open it in output mode. And if we then want to read data from it, we would have to close it first and reopen it in input mode. So how do we write data to a file? For this, we use the write command, and we use it in this form here, write D, where D is the data set that we associated to the internal file F via the fdf instruction. And to use the write command, we need to open the file as output or extend, or in some cases also IO works. Optionally, we can end this command with end write. Now, we have talked about how COBOL files can sometimes store different data types, let's say D1 and D2, if we assign multiple records in the FD statement. And then we would have to explicitly mention which one of these types we use to write the data. Now, if R is any record defined in the working storage section, so not necessarily one that is associated to F via the FD, then we can write this record to the file using write D from R. So what this does is the same as this. So first we would move the content of R to D, so to the data structure associated with our file, and then we write D to the file. And now, of course, if R is defined in the working storage section and not necessarily identically defined to D, then it will be the programmer's responsibility to ensure that the types of D and R are compatible so that this right here makes sense. As I said before, once we open the file, the position in the file will be the beginning of the file. So what happens here is that COBOL keeps track of the current position in the file internally. So this is not transparent to the programmer, but the compiler takes care of that. And then after each write operation, it advances the position by the size of one record within that file. So if you have two consecutive write operations, then these will be written in two properly spaced out positions in the file, so you will not overwrite the previous records. It is possible to associate a printer with an internal file, F, and in this case you can use the write command with some additional options to format the data for printing on a page, but this is not something I will discuss here. So if you're interested in that, then know that it is possible, but you would have to look it up on the internet. Okay, so let us explore in a little example how we can use the write command. So here I have my program where I want to first enter some code to accept data from the terminal and then write this to a file. So first I actually have to connect my internal file, which I just call data file here, to some file on disk, and I will just call this records.dat. Then the next thing I have to do is in the data division, I have to prescribe the records that are to be written in this file. So here fd data file, my internal file name. And now, I just call this data set, the record name, and two entries. So one for the name, which is a string of 20 characters, and let's say also an age, which is a 3-digit number, or at most 3 digits. Also, I would want to have the user decide how many entries we should write to the file. So I will define a variable n, which will hold the number of records that we write to this file. Let's say 2 digits should be enough for that, because we're going to manually read it, so we don't want to have too many of that. Okay, first we will ask the user how many records we want to write to the file, and this gets read into this variable n. Use these little lines to make the output a bit more readable. And now we will read the data for our file, and the first thing we have to do is to open the file for output. And I want to read in n records, so I will have a loop, for reading n entries in the file, perform, and if we remember from our chapter on control flow, this is how it goes. So perform test after, so we check n after the loop. We use the tally variable as a loop counter. Until the tally reaches n. Now we will ask for the entry. We will have to read name and age for each entry. So we display the record number, which is just the tally. Then we will ask for the age. And once we've done that, we will write our data set to the file. So let's go through this briefly. We read data name and data age for this record here. And then I say write data set. So we write this record, and because this record is associated to data file, it will be written to data file, which is actually records.dat. And once we're done with that, we have to close the file. Let's compile this. And of course we get an error. Keyword from is missing. Unexpected end perform. Yes, there shouldn't be a period here. Okay. This time it works. How many records? Let's say 3 records. And yeah, let's just go with the Simpsons again. Name is Homer, age is whatever, 39. Mr. Burns, age is 99, and Maggie, whose name is 1. And that's it. So let's see. Yeah, so there exists a file records.dat now, and the data inside of this file corresponds to what I've entered here. So this all seems to work just fine. And next up, we want to read a record from this file again, and I will explain how we do that now. To read from a file, we must open it as input or as IO. And then the read command is straightforward. We say read F. And so notice the slight difference to the write command. For the read command, we actually give the internal file name, whereas for the write command, we gave it the name of the record that was associated to the file name. So be careful not to confuse the conventions here. So if in our file we can store different data types, D1 or D2, then we can use the into clause to make it explicit which type we are actually reading from the file at the moment. So read F into DI, and then we give the name of the record that we want to use to read data from the file in the current operation. Again, you can optionally end this command with an end read statement. Just like the write command, the read command also advances the position in the file F by the size of the last record that was read. What we can do here is that in addition, we can specify a clause at end to handle the case when we reach the end of the file. So it's like this: read file name at end C. And here C stands for a sequence of commands that is executed when the end of the file is reached. So it's not just one single command. We could put in multiple commands after that. And similarly to the at end command, or the at end clause, there's a not at end clause. And here we can specify some action that is to be performed, well, before we reach the end of the file. So if we're not at the end. This is not always necessary to do that. Usually once the read statement is over, you can do something with the data you've read from the file. But in some cases, you actually have to use the not at end statement if you use the at end statement before. So the read statement knows when the conditions or the commands following the at end clause are over, and the commands that should be executed if you're not at the end of the file follow then. Good. Now let's see how we can read something from a file in a practical example. So here we've written something to the file. We have orderly closed our file now, and now we want to read from the file. And we have to open it as input. Yeah, I will just loop through the file and print out all the entries in the file. So pretty much the same as we did before. Again, forgot something here. Now we have read data file. So here we give the internal file name, not the data set. I use the at end clause, and what I will do is at end display premature end of file, because we shouldn't get to this position because we are, well, having n iterations, so that should be exactly the number of entries in the file. But if for whatever reason n would get corrupted, then we might reach the end of the file prematurely, and in this case I want to display this warning here, or this error. And what we would do is we use the next sentence command to just skip out of the loop. And I have to use the end read here because we're in the perform loop, so I can't use any periods to end statements here, because then COBOL would interpret this as ending the perform statement. So in order to tell the code in the loop that the read statement is over, now I actually have to use end read here. And now I want to display the data that I just read. And that's it. It's the end of the loop, and again we close our file, and that should be it. So yeah, what we do, so we still have the number n of total records in our file. That hasn't changed from here to here. So we iterate from 1 to n, so over all the entries in the file. We use the read command to read from the data file that gets automatically written into this data set here. Then we print out the parts, the components of this data set, and then we iterate on to the next entry in the file, and again this is read and we print it out. Let's recompile. Now I have to enter the records again. Let's maybe enter some other names now. Overwrite was what was in the file before. So who do we have? Net Flanders is also, I don't know how old they are. And buy, and let's say it's 40. I don't know. And yeah, so here I entered them just like I did before, and this is now the loop where we read the file and print it out. So it's exactly what I entered here before. So this all works lovely as we expected. There are some other file operations in addition to read and write. So if we open a file as IO, we can use the rewrite command to overwrite existing entries in a file. And this command essentially can be used exactly like the write command, but it is applied to a file already containing data. Even though, as the example we just looked at showed us, we can also use just the write command to overwrite a file as if it were a new file. But the rewrite command should allow you to do that in a safe way without compromising any data that is previously contained in the file that is not meant to be overwritten. Before we want to rewrite any entry in a file, we must first read this entry with a read command. And so in the IO mode, we can use both read and rewrite without having to close and reopen the file. Then we can use a delete command on files that are opened as IO to delete existing entries from a file. And again, before we delete an entry, we first must use the read command to read this entry. And for the relative or indexed files, so you remember in the beginning I showed you these three file types. So those files that are not sequential files, we can use the start statement to move the internal position in the file at which we want to read or rewrite or delete data. For this, it is necessary that the file allows us to access its entries via a certain key. So we will see that in more detail later, how this works. And then we can use this key combined with the comparison operator in the start command to determine the new position in the file. And as I said, this only makes sense when we are using non-sequential files, but we will see this in more detail later. Now, I first want to show you how you can do exception handling in COBOL. Now, COBOL provides some mechanisms to deal with exceptions and errors when handling files, and we've seen one such mechanism in the @end clause for the read instruction, so where you handle the exception that you've reached the end of the file. We will also see later that there's an invalid key clause for relative or indexed files that will handle the exception or the error that your key is not matching any entry in the file. But more generally, you can declare a variable as the file status variable for a particular file, and this variable will then automatically be set after each file operation. And depending on the value, you can, well, either you check it manually and decide to execute some code, or you can actually predefine an error procedure that will be automatically executed depending on the status that is returned by the file status variable after a file operation. And to declare a file status variable for a given file, include the clause file status is S in your select statement for the file. And here S is just the name of the variable that should be your file status variable. This variable must be declared in the working storage section, and it has to be a variable consisting precisely of 2 alphanumerical characters. And I recommend to do this as a record so it's easier to access the individual characters. So it would look like that. So here in the file control paragraph, select assigning your internal file name to some external file name. And instead of the period here, you include the clause file status is, and I just call it test status because it's test file. And then test status is defined here in the working storage section. And I define it here as a record with 2 picx entries, so with 2 entries that are each 1 character long. So this whole thing consists of precisely 2 characters, and we can access them directly via their names and numbers here. And after each operation on a file, so after each operation on test file in this case, the value of the file status variable can be read, and you can take some action, or you can use these automatic exception handlers. Now, I said the file status variable consists of 2 characters exactly. And the meaning of these 2 characters is that the first character determines the class of the status, and the second character encodes a more specific subclass. So the class is think of it, the general type of error or exception, and then this gets made more precise in the second characters. Now the first character, the general class, can have the following values with the following meanings. So if it's 0, then nothing bad happens, so it was just a regular execution of the file operation. That's good. If the value is 1, then the at-end condition occurred, so that would be the same as when the at-end clause in a read command would get triggered. If the value is 2, then an invalid key condition has occurred. If the value is 3, then a so-called permanent error has occurred. For example, if the file you want to read or open doesn't exist. And 4 means an error in the logical order of the input-output operations has occurred. For example, if you want to read from a file that has not been opened yet. And then there's value 9 reserved for other types of errors. And the meanings of the second character, there are so many that I cannot really show them here. But on this link, you can look up all the values that are defined for IBM COBOL. And you will see that's actually quite a lot. So here we have the error codes for IBM COBOL. And you see 0, again up here, is considered successful execution. 1 is at end, and so on. And here are the meanings of the second character as well. So you see them grouped by the first character, and then going through all the meanings of the second character. For example, 1.0 is just end of file. 1.2 attempted to open a file that is already open. It's not really an end of file thing, but okay. And you can just go through this list and see what the error codes mean if you ever need that. Now let's look at an example for how to use these file status variables. So you see here I have a program with an internal file assigned to a system file, and as the name here strongly suggests, this file does not actually exist, so I will cause an error of trying to open a file that doesn't exist, and then see how I can use the file status to handle that. What I need to add here first is the file status is clause, and I call it test status. And then I need to add this variable in the working storage section. So here's already the data set for my test file, or my alleged test file. And here I define my test status variable as a 2-character record. Here I want to open the input file, and as I said, this file doesn't exist, so I expect to get some error here. And let's see what happens. I expect the error status to be written to test status, so I'll just print that out. First the full record and then the individual bytes. And this should work. So let's compile it. Yeah, so we get 3.5. File status class is 3 and subclass is 5. So maybe let's look up what that actually means. We had 3.5, so let's go down, file not found. Yeah, that makes sense. So 3 were these so-called permanent errors, which are problems with the files themselves. So 3.5 means file not found. That is exactly what we would expect when trying to open a file that doesn't exist. Instead of manually analyzing the file status, we can actually define error procedures in COBOL, so some ancient form of exception handlers, if you like. And to do this, you must proceed as follows. At the very beginning of the procedure division, so where your actual program logic starts, beginning in area 1, so that is column 8 of the editor, the keywords declaratives and declaratives mark the code area reserved for the declaration of error procedures. So this is where your exception handling code goes, at the very beginning of the procedure division. And the code in this part, so the code between these two delimiters here, is not executed when the program starts, but only when an appropriate exception is invoked. And the error procedures must be declared as sections between these two keywords here, and the names can be chosen freely. So you can pick some good names to indicate what you're referring to. And immediately after the section declaration, so after the section name, you formulate the condition for when this particular exception handler will be invoked. And this is of the form use after error procedure on x1, x2 with the following meaning. So first, the error can be replaced by exception, so it's the same meaning. And x1, x2 is either a file name, so an internal file name, which means the procedure is executed when any error occurs for this particular file. But these have to be files that are defined with FD, so you can't use sorting files, the ones defined with SD for these error procedures. So you recall in the chapter on control flow, we had the sorting mechanism of COBOL, which used some external files to sort, to buffer the sorting data, and these were defined with a SD descriptor. So these are not allowed here. So you have to use a file defined with FD, so the ones we're discussing here in this chapter. Or instead of a file name, you can give one of the opening file states. So you could write input, output, IO, or extend here. And in this case, the error procedure would be launched anytime a file opened in this state would have an error. And it doesn't matter which file this is. Now, of course, you can get some conflicts here because you could have a file that has an exception handler for its particular name, but is also, let's say, opened as input. But if there's also an exception handler for the input state, then you would have two exception handlers and maybe they would be contradictory. So how do we deal with that? First, each file name can only occur in at most one error procedure. And if you have a file that has its own error procedure but would also invoke an error procedure for the file opening state, then the one assigned to it by its name takes precedence. So the error procedure for the file name takes precedence over the error procedure for the file state. So let's see in our example how we would implement such an exception handler. As I said, it has to be at the very beginning of the procedure divisions. Declaratives and end declaratives. So here between those two keywords we have to write our exception handler. So let's just call this test error because our file is called test file. Section because we have to define them as sections. And the first thing we have to do is write down the condition when this gets invoked. Use after error procedure on, and I'll make the condition dependent on the file name. So this is, if any error occurs for our test file, then whatever comes now will be invoked. And I have a bit of a lengthy statement here that I will just copy in. What I will do, I will print caught exception, and then I will print the exception code, test status first character, and then in parentheses the second character. And yeah, just for fun of it, I will print out what the meaning of at least the first character is. If you really want to take this to the extreme, you could look up all the meanings of the second characters on that website I showed you before and also print that out here. But yeah, that would be a bit excessive and unreadable. So for the sake of demonstration, I will just use this. So whenever any error occurs with test file, this will be called. And then I will just print the type or the general class of the exception or the error. And what we expect, of course, is since the file associated to our internal file name does not exist, this will be called. So first we will print, no, actually first we should call this, and then we will print all the stuff that we had before. Yeah. So we see here, caught exception code is 3.5, permanent file error. So we look up the exception code here, permanent file error, and then we get the stuff that we already printed previously. Yeah, and we get another exception because here's the close statement, a different error this time. I assume 4.2 that error in the logical order, so I suppose this means we try to close a file that has not previously been opened. Makes sense that this would cause an error in the logical order. And yeah, so we see two different types of errors in this little program here and see that the exception handling mechanism works well. Now we're going to look at the particular file types that COBOL offers us. So first I'm going to look at the simplest one, the sequential files. In a sequential file, the records are accessed in a continuous manner. So the only way to access a particular record in the file is to iterate through the file through the previous records in the order they were written to the file in the beginning. And historically, this is a very important type of accessing files because from the 50s up into the 80s, external data storage was usually done using magnetic tapes. So here's a rather old one, and one by IBM, where you have these huge tapes that would store your external data. And yeah, these tapes can only be wound in one or sometimes in the opposite direction. So you cannot just easily go backward and forward quickly on such a tape. So it makes sense to read data sequentially and organize your data accordingly. Nowadays, of course, we have, well, there were originally floppy disks. These are not in use either anymore, but floppy disks and hard disk drives made these magnetic tapes somewhat obsolete. But even today, they are still used as a low-cost option for storing very large backups. So if you just need to store huge amounts of data in a cheap way, but there's no need to have really quick access to that data, then tape drive is actually still a reasonable option. Of course, they don't look like this anymore. And as I said, by their technical nature, the only way to access these tape drives is by sequential access of data. So if you indeed work with a tape drive, then you must have sequential files. But of course, on other storage media, you can also save sequential files. Now, COBOL assumes by default that a file is sequential unless you tell it that it's some other type. So if you give no other clauses in the select statement that assigns your internal file to the system file, then COBOL will assume it is a sequential file. Still, you can make it explicit just to make your source code clearer by including the clause organization is sequential in your select statement. So this would look like this. Here in the file control paragraph, select data file assigned to records dot, and no period here, but rather organization is sequential. It's redundant, but as I said, to make your source code clearer, you can do that. As I mentioned before, COBOL keeps track of the current position within your sequential file or any file internally. So this is not transparent to you as a programmer, but it will be consistent throughout the file operations. So when a sequential file is opened with open, the position is set to the first record in the file. Makes sense. Each read and write operation advances the internal file position to the next record. So you move on as many bytes as the size of your data structure is. And you do this until the end of the file is reached. And if you want to read or write more data then, well, you will get an at end of file exception. And you do this exactly like we discussed it before. So there are no special parameters to be used for sequential files. You can use the rewrite command, but only if the file is opened as IO. And this can overwrite a record in the file if you previously read that record with a read command. So you iterate through your sequential file until you find the record that you want to overwrite. Then you read that record. You would probably have to read it anyway to check which record you're actually looking at. And then you can use rewrite to change the record, but the rewrite command will not advance the file's internal position. So that's how it differs from the read or write command. And delete or start cannot be used with sequential files. So let's have a look at an example of a sequential file. And here I've pre-filled most of the file already because it's pretty much what we saw before. Important to notice, here I made it explicit that the organization of the file is to be sequential. Then we define our data record for the file just as we did before. I use again the same structure with name and age in it. I use the same file that I used before, so this should still have some of the Simpsons names in it and their ages. Now I ask how many entries we want to display, and then I just read out the first n entries in the file and show them. So yeah, there should be 3 entries in the file because that's how we saved it in the previous example. let's find out if this works. Yeah, if I want to print one entry, I only get 1, 2 entries, 3 entries, and if I want to print 4 entries, I get the premature end of file. So the at-end exception gets triggered, and I move on to next sentence and yeah, close the file. So this is all working nicely as you would expect it. Now, one thing I want to show you that's particular for the sequential files is how to replace a record. So I'll just replace the first record for simplicity. So I have to open it as IO. Notice the file was closed before, so it's okay to open it again. And I will read data files. So the first record, when I open it, the internal position is at the first record, so I read it into the structure here. And then I ask for new user input to replace the current record. So there's a new name that needs to be entered. And a new age that needs to be entered. And then I use the rewrite command. And just like with the write command, I don't use the file name here, but I use the name of the record dataset which is associated to this file. And finally I close the file again. Okay, so I don't move the position, so the first record should be replaced by this operation. So let's see, the first record here is March. I recompile. 3 entries. And now let's see, Mr. Burns, new age is 99. Okay, and let's check. Yeah, so here we had March, now we have Mr. Burns as the first entry. So we did replace the first entry, and the second or third one were unchanged. They're still the same as they were in the previous call. Now, just for reference, here you have an overview of which file operations can or cannot be used with a sequential file depending on how it was opened. So here are the operations: write, read, rewrite, delete, start. And if you open it as input, output, IO, or extend, then you can use read or write or rewrite depending on how you opened it. And delete and start, as you can see, cannot be used at all with sequential files. So yeah, this is just as a reference for you. So if you want to have a longer look at it, just pause the video. But we're moving on to relative files now. Relative files are those where the records in the file are numbered sequentially, so in the order they were written to the file. The indices are beginning at 1, so they're not beginning at 0 like they would in a C-style language, but they begin at 1. And you can use the index of a record to access this record directly without having to iterate through the previous records. For this, you have to include the clause organization is relative in the file's select statement. It would look like this. File control, select data file assigned to records dot. Organization is relative. And you can already see we require some additional parameters for this. Access mode is random. Relative key is rel key, where you see this relative key appears down here in the working storage section. So let's see what this actually all means. If you use the select statement with organization as relative, you must include an access mode. So the access mode is X clause, where X can be one of the following: sequential. In this case, you actually treat the file as if it were a sequential file. So if you use this access mode, you can only read the records one after another, beginning with the first one. Why do you even include that? Well, you might have files that are not saved to disk as sequential files, but you want to treat them like sequential files in a particular program or part of a program. So that's why you can use access mode is sequential, even if the file organization, the file type, is relative. Then there's random. So for random access, this is what relative files are meant for. And here you can access records by their index, and to do this you must declare an unsigned numerical variable k, or here I called it the rel key, the relative key for this file. And the value contained in this variable here will be the index of the entry of the file that you will access. And you make this declaration with the clause relative key is k. So relative key is, and then the name of the numerical variable that will hold the index for your file entries. Finally, there's dynamic access mode. And here you can combine operations from sequential and random access. And in this case, you also have to specify the key variable, because if you combine random and sequential access, then of course you need the key as well. Now, to write to a relative file, you have to use the output clause. You cannot use the extend clause for relative files. And you can use the command write D or write D from R, just like we discussed them before. So either you write directly to the record associated to the file and then write it to the file with this, or you have some other data structure that you first write to in your program logic, and then you move this data to D and then write it to the file. Now, if the access mode is sequential, then the file behaves exactly like a sequential file, so there's nothing new there. So let us now assume that we have access mode random or dynamic. And in these cases, random or dynamic, the position in the file at which the record is positioned that we will write to is given by the relative key that we defined in the select statement. And of course, the value for this key must then be set before the write command is performed. And we don't have to specify it explicitly in the write command. It will be automatically used, because from the file declaration, from the select statement, COBOL already knows which variable to use. And in addition, we can supply the invalid key clause in the write command. So we could write D and then follow this by invalid key C. And C here stands for the commands that are to be performed if the value in our key variable does not match any entry in the file. So, for example, if the index is larger than the number of records in the file. And then we perform this exception here, and the code C is executed. And there's a corresponding clause, not invalid key, C prime. So that obviously means this is the code you execute if your key is legitimate, refers to a proper entry in the file. So this would be the normal case when writing to a file. Let's see an example. All right, here first I have to declare my relative file. I just use the same method, same internal file name again. Now I call this rel record. So here are the relative records. No period here actually. Organization is relative, so this is required. Access mode is random, so we want random access. If we use sequential access, it would be pretty boring because we would just be doing the same stuff as before with the relative files. And yeah, let's call it the key, the rel key, relative key. Now in the file section, I declare the data set for my internal file, just like I did before. Again, the one with name and age. And in the working storage section, I have to declare my relative key. So this will be the one that COBOL picks to access the elements. So it's a numerical one. And I will also use a numerical variable to count the entries in my file, n. Okay, so here you see I already prepared a few things. I want to write records, read records, and delete records. So for now I'm just going to write something here. And again, I ask the user to enter how many records he or she wants to enter into the file. Here I have the special condition, if n equal to 0, then go to read records. So I don't have to go through the writing records all the time. So if you say I want to enter 0 records, then this part just gets skipped. Okay, we talked about the write command, so let's write some stuff to our data file. We open the file as output. And again, I will use the perform loop that I used before. To have the user enter name and age for the current record. We're iterating until we get to the number n that we entered here. Now, to get the data written to the correct position, I have to set the variable rel key. I have to set my key variable to the position that we're currently looking at. And so I just move the tally, my counter variable, to the relative key. I could have also used relative key as the counter for the loop, but I want to make it a bit more explicit here. And then I write to data file, which should be the file rel records now. And because I declared rel key to be the relative key here, COBOL will automatically know that in this write statement it has to use the value here for the position of where to write. And perform. And as good data citizens, we close our file. Include some of these little dashes here to make the output more readable when we continue later on. Let's compile this. And we have errors. Let's see. Right, yes, I have to use data set. And did I have another period in here? Yeah, no period here. How many records? 3 again, always the same ones. Homer, Mr. Burns and Maggie, and that's it. Yeah, that worked. So I entered the 3 records here, and if I cat the file, we'll see that's what's in the file there. Good. So we've seen that writing to relative files by accessing them via their keys works nicely. Now we want to read from relative files. To do this, we must open the file with input or IO. And as before, we use the command readf, where f is the internal file name, and can use it in the same way as we discussed before with the into, at end, and the not at end clauses. Moreover, if the access mode is dynamic, then we have to use the keyword next without any argument in the read command to advance the position in the file to the next entry. So that's because in dynamic access mode we can access the file sequentially or by the index, and imagine we previously accessed the file via its index but then want to do some sequential reading, it wouldn't be clear whether we should advance the position after the read command or not. So here we have to make this explicit with the keyword next that could follow this readf command here. And in random or dynamic access mode, the position in the file from which we read is always the value in the relative key variable. And again, of course, this value has to be set before we execute the read command. We can add the clauses invalid key and not invalid key, just like we do in the write command for the situation where the key is set to a value that is not matching any entry in the file. So, for example, if the key is larger than the number of entries in the file. So let's look at the example. Here's our file again. We already wrote some data to the file. Now let's read some data. Open data file as input. And now I'm asking which record do we want to have displayed, and then we just enter the number of the records that we want to see. So we are reading the value for our relative key directly. Read data file. Here we really have to give the file name, not the record name. I will have the exception handler for the invalid key. And I will just display a message that the key is invalid. And then I will close the file, and of course I should not use periods here, otherwise the read statement will end prematurely, and I will use the end read. Usually this is optional, but since I have several options in here or commands in here, I want to make it more explicit where the read statement ends. And then I want to show the record that we just retrieved. Record number, whatever is in the relative key variable. And the usual finally we close the file. Okay, so we ask for the key, the index of the record we want to show. Check if it's valid. If not, we stop the program. Otherwise, we'll print out the key. Now we have these 3 entries here. You can also see the indices here. So let's say I'll ask for record 2, then I expect to see Mr. Burns. Compile, run. So I'm not going to enter new records. So I enter 0 here to skip the write records. I want to read record 2, and indeed I get Mr. Burns, just like I entered it up here. Let's try it again for an invalid key, so not entering anything here. Let's say I want to read record number 8. Of course, that gives an error because there are only 3 records, so I get the appropriate invalid key message here. Now the rewrite command can only be used when the file is opened as I/O, and regardless of the access mode, it overrides the entry of the file at the file's current internal position as determined by the key variable, or if it's in sequential mode, wherever we move to in the file by reading previous records. And this does not change the internal position in the file afterwards. To rewrite something, we must previously read it with the read command. And aside from this, rewrite is used just like write command. So the same clauses as in the write command can also be used in the rewrite command. And to delete an entry from a relative file, we must open it as IO and then delete F in any access mode will delete the entry in the file at the current internal position of the file. And this does not change the internal position afterwards. And again, just like with rewrite, before deleting an entry, we must read it with a read command. In random or dynamic access mode, the relative key variable determines the position where the entry will be deleted. And again, we can use invalid key or not invalid key to handle values for k. Now, if I try to use this with GnuCOBOL, it appears that the delete command has no effect. So I can show you this. It should work according to COBOL standards, but in GnuCOBOL somehow it does not appear to do anything. So here I just copied in some code to delete an entry in the file. So I asked the user which record to delete, read in that value, then I read that record because I have to read it before deleting it. And then I use the delete command to delete it. Let's see what happens. Recompile. No, not. Okay, let's delete Mr. Burns, the second entry. Okay, now it should be gone, but if I cat the file, then we see Mr. Burns is still inside this file, just like it was before, and nothing has changed. And if I rerun it, oh no, actually something did happen. Aha, that's interesting. So apparently COBOL keeps, oh yes, okay. Maybe there is some additional data in this file, I'm not quite sure. It's not really obvious from this format. If there's some kind of marker that invalidates this second entry. So even though the data is technically still there, some metadata in this file makes it invalid, so you can't access it anymore. Let's see if I could still access entry 3. Yes, so yeah, so the key 2 has been invalidated. That's actually quite interesting. So you don't have a really continuous sequence of keys anymore. So it does appear that GnuCOBOL deletes it correctly after all, and it's just keeping the data within the file but treats it as if it were deleted. Of course, not a very safe way of handling sensitive data. Now, the start instruction is something we can use in a relative file, and this allows us to set the internal position in a relative file for subsequent sequential processing. This could be with read, rewrite, or delete. So this is for access modes sequential or dynamic. So the two access modes where we can perform sequential processing. And the file must be opened as input or as IO. And this command is a bit involved. So we have start F, where F is the internal file name. And then key is omega k, where omega stands for a comparison operator. So here we have a comparison operator that is equal, greater than, not less than, and greater or equal to. You could also write them out in words, but that's horrible. And k is the key that holds the current position in the file. So it's just your key variable. So you can set the key variable to something particular and then tell the file or tell COBOL to position yourself in the file relative to that key, depending on the outcome of these comparisons. Again, you can use the invalid and not invalid key clauses and optionally end the statement with end start, which sounds like a bit of an oxymoronic word. After the start command, the position in the file will be at the first entry that satisfies the condition given by this comparison omega, one of these, with the value in our key variable. And technically it is possible to omit this clause here, but in that case start will just set the position to the value of the key. So that is what it would do for subsequent file operations anyway. And again, for reference, I'll give you an overview of which operations are possible with the different modes to open the file. So pause the video to have a closer look at that. This one is for a relative file with sequential access mode. And you see we cannot use the extend at all, so that's not valid for relative files. Here we have the operations possible for relative files in random access mode. And here we have the operations possible for relative files in dynamic access mode. And with that, we move on to indexed files. So indexed files are similar to relative files and can be used in a similar way. But here we do not use the position in the file as the key to access its entries, but rather we use a string of fixed length. So we use some alphanumeric data. And in that sense, you could compare these indexed files with dictionary files in other languages. Now, one difference to the relative files is that the key we use to identify the data, the records we want to access, has to be part of the record that is associated to the file in the FD statement. So before, the key for relative files was a separate external variable, not contained in the data structure for the file. But here we use the data in the file directly to access the entries. To tell COBOL that a file is supposed to be an indexed file, we use the clause organization is indexed in the select statement. And it would look like this. So here select data file assigned to int records dot. Organization is indexed. Again, we have an access mode, random, and record key is data name. So here we don't call it relative key as we did for the relative files, but we call it record key. And I choose data name, and you see data name is an entry contained in the data structure that is associated to our file. And that's required for the indexed files. Again, let's go through this. I'll maybe do it a bit more quickly because it's practically identical to what we had for relative files. So we have the access mode is X clause, where X could be sequential. Again, in this case, we just treat the file as if it were a sequential file. We have random, where we can have random access to the entries in the file. To this, we use the record key. So we determine which of the entries of the components of our file record is to be used as key. And that is how we access entries in the file. And we can also have different keys. So the record key is blah blah. That will be the default key to access entries. But we can use other keys as well. And we declare these with the clause alternate record key is, and then some other entry in our record. So here I use name as the main key and then age, data age, as the alternate key. And if we want to use an alternate key instead of the main key, then we have to make this explicit in the file operations. We do not have to make the main key explicit. It is assumed to be the key we use unless we explicitly say we should use an alternate key. And again, we have dynamic access mode, which just combines random and sequential. We can write to indexed files just like we did with the other files, so with write D or write D from R. And if the access mode is sequential, again, then the file behaves like a sequential file, so assume that we have random or dynamic access mode. And in these cases, the position where we write a record will be written to the value record key, so the value contained in record key. So we look at the record, the data structure that's defined for our file, look at the component that was chosen to be the key, and the value in there, that will be the record we address in our file. And for write statements, we actually cannot use the alternate keys. That is, we always must have, when we first write the data, we always must specify a value for the main key. We can again use the invalid key clause with a sequence of commands that we execute if the key is not valid. So if the format of the key is not alphanumeric or something like that, then we might have this invalid key exception. And again, there's a corresponding not invalid key clause that we use if the key is in fact valid. We can read from an index file if we open it as input or IO with the usual readf, and we can, as before, use clauses into, at end, and not at end. Now, if the access mode is dynamic, then again we require the next keyword without arguments to advance the position in the file if we read from it. So if we want to use sequential access to the file, we explicitly have to advance the positions in the file. Again, this is just like we had it for the relative files. And in random or dynamic access mode, the position where we read from the file is given by the value in the record key, which will be used by default without us having to specify it explicitly. But if we wish to use an alternate key to access a record in the file, then we must include the clause key is K2, and here's the name for the alternate key. And we use this clause in the read statement. Now, the clauses invalid key and not invalid key can be used just as in the write command. So let's look at an example for this. Now here I have a program for indexed files, and I pretty much want to do the same thing as I did before for the relative files. So not much will change here, but I want to highlight the differences that do occur. No period, sorry. Yeah, organization is indexed, of course, and then we do the same as before. Access mode is random. Record key is data name. So I haven't specified the data structure for the file yet, but we will see it will contain data name. I will just use the same structure that I used for the other examples. And no, it's not alternative, alternate record key is data age. Okay, yeah, and in the data division we'll have the same stuff as before, so I'll just copy it in. Here's data file, the record associated to our file here, and we have data name that was declared to be our main key, and data age was declared to be the alternate record key. Now what I want to do, again, I asked the user how many records to enter. If it's 0, then I will skip the writing part and go straight to the reading part. And this is very similar to what we did before. So again, I'll just copy it in here. We open our data file as output and loop over the number of records I want to enter and just write it to the data set. Now, this data will be indexed by data name. So what will actually happen is that COBOL writes some metadata to the file so that we can access the data sets by their data name entries. And then we will close the file. How many records, and just write them down in a different order now. Maggie, Homer, and Mr. Burns. And that's it. And you see, we actually have two files now, one that was created by COBOL in addition to the main data file, but first we kept this. Now what you see here, other than what we had before with the sequential or the relative files, where you just saw the raw data in the file, here we actually have some metadata at the beginning of the file. And you see that the name, so the keys actually, so the names are the main keys for our data sets. They appear twice. So this, I guess, means that this is the way in which COBOL saves the keys that are used to access the data later on. Just view this in hexdump. Yeah, you see it's quite a bit of space at the beginning of the file, and yeah, if you really feel like it, you could try to reverse engineer the file format. We will look at it a little bit later on when we do the delete operations. And yeah, there's also this second file associated to this records dot, the dot. And you see this looks quite similar, but here the keys don't appear. Yeah, so I guess this is also somehow used by GnuCOBOL for the indexing procedure. Interesting. Now let's continue in our program here and read some record. Maybe I type this out explicitly again. So the file has been closed after the writing, so now we open it for input. Again, we ask which record to read and remind ourselves that we actually have to enter the name. So if we just enter an index, that won't work here. We have to enter a name, and we read this into the data name. So we actually read it into our data set associated to the file. And then we read data file. So now we set the name in this data set here. And when we perform the read operation, COBOL will look at the name that's currently stored in here and then retrieve the record with the matching name if it exists. We use the invalid key clause again. Display key. Close the file and exit the program. Yeah, and then we just display which record we just read out, if everything worked properly. And we close the file. So we already entered some records before, so the file is not empty. And now let's say I want to read Maggie, and yeah, so retrieving record with key Maggie, and indeed I get the record that I saved before. Let's see if I enter an invalid name. Yeah, then I get the invalid key exception here, just like it should be. And you also see if I enter an index for a record now, that's not valid. Wrong type of data. We also have the rewrite command for indexed files, and this is exactly like you would use it for relative files. So I'm not going to discuss this in more detail. And yeah, position is of course given by the key, and you must previously read the entry to be rewritten with read, and then you can use rewrite essentially like the write command. To delete an entry from an indexed file, you must open it as IO, call deleteF, which would delete the entry at the file's current position. And previously you must read the entry with the read command. The file's internal position is of course given by the key, the record key in this case, and you can use the clauses invalid key and not invalid key again. Here we're back in our program and I open the file as IO. Ask for the record that is to be deleted, so again I have to give the name here because this is our main key. I have to read the record first before I can delete it, and I will use the invalid key clause here, just like I did with the read statement before. Then I use the delete command on data file. It will automatically pick the right position by the value that we read in with this except statement. And we close the data file and stop the run. So let's read Mr. Burns. That is correctly retrieved, and now I want to delete Mr. Burns. So let's try again. If I run the program again and I try to read Mr. Burns now, I get an invalid key. So here it still worked. Read which record, Mr. Burns, retrieving data. Now I do the same thing, but I get invalid key because I deleted this entry before. And again, let's have a look at how this looks in the file. So yeah, you see again, like with the relative files, the data is still in there, but I assume something must have changed at some point. Yeah, here something has been overwritten. So not quite sure how GnuCOBOL arranges these files, but we see Homer and Maggie still are here properly with name and age, and Mr. Burns, the age is missing, the name is truncated here, so yeah, COBOL must have done something to invalidate this record in this auxiliary file here. And for all intents and purposes, Mr. Burns has been deleted from our indexed file. And for indexed files, we also have the start instruction that allows us to position the initial position when reading, writing, or deleting from a file. And the format is exactly the same as for the relative files. We have start F, key is omega k, where omega is one of these comparison operators and k is the record key pointing to some element in the file, or it could be one of the alternate keys if you have defined alternate. You can again use invalid or not invalid key clauses and optionally end the whole statement with end start. And if you execute this command, then as with the relative files, the position in the file will be the first entry that satisfies the condition given by omega, the comparison operator, and the value in your key file. You can omit the key clause, but then you will just use the value in your key file, so the default thing. And again, for completeness, I list the operations you can perform on indexed files given how you open them. First, for sequential access mode, here you can actually use the extend mode of opening the file, and then you can use the write statement only for that. Here we have the situation for random access mode, which I think is identical to relative files, if I remember correctly. And here we have dynamic access mode for indexed files. That's it for the different file types in COBOL. And now I quickly want to talk about dynamic file names. That is, file names that are not hard-coded into the program, but actually can be determined at runtime. And every now and then you might want to use something like that. So write a program in which the name of a file needs to be determined at runtime. For example, if you want to work through a list of files and you don't know the total number of files to begin with, so if it's file 1, file 2, file 3, and you would want to dynamically generate the file name in this manner and go through them sequentially, or if you want to search through the files in a directory and you don't know which files are in there by default, or when you create a file whose name should depend on some runtime information, for example, the current date, just think of log files that would include the current date, then you would want to be able to generate file names dynamically. Now, in COBOL, every file name has to be assigned to a fixed system file name, like this. So, how would you do this in COBOL? Or can you even do this in COBOL? And the answer is, that depends. Now in classical COBOL, the answer is simply no, you cannot do that. It is not possible to vary the system file name within the COBOL program. And that's that. The only way you could vary the file name, for example, if you're on a mainframe system, then you would have to do it outside of the COBOL program in the operating system environment. For example, the job control language script could possibly vary the file name and assign different actual file names on disk to the system file name, and then you would just have to call the COBOL program with that system file name repeatedly, and each time a different real file name would be associated to that. But that's about as much detail I can give you on that, because I'm not that knowledgeable about IBM's programming environment outside of COBOL. If I ever understand how this works properly, I will surely make a video about it, but do not hold your breath waiting for that. Now, GnuCOBOL and several other modern COBOL dialects, however, provide a mechanism how to do this, how to have dynamic file names. And it's very simple. You just declare your system file to be dynamic, and then instead of giving an actual file name on your disk, you provide an alphanumerical variable from the working storage section that will hold the file name. It looks like this. File control, select data file, our internal file name, assign to. Normally here you would have the hard-coded file name on disk, but now we have dynamic my file name. This is just the name of some variable which you declare here in the working storage section. And then you can just change the value for file name, and that will determine the file that you're accessing when you refer to data file. Interestingly, this feature is even accepted when we compile, when we use GnuCOBOL and use it with the compiler flag standard equal to IBM, because the IBM COBOL standard does not officially support this. So if you look at the programming guide or the language definition of IBM COBOL, there's nothing about this dynamic here. So that's, let's say, a convenient feature that GnuCOBOL does actually allow us to use it even in the IBM standard. So I guess if you write a COBOL file with a dynamic file name with this flag on, then it would not be strictly IBM compatible. You should not expect it to run it on an IBM machine. And it will actually cause an error when you compile it with IBM strict. So maybe this was a conscious relaxation of the IBM standard by the GnuCOBOL developers. I don't know exactly why they allow it in the IBM standard, but for us it is convenient because we can use this feature to make our life a little bit easier, even though we are otherwise strictly adhering to the IBM COBOL standard. So let's have an example. Here we have the skeleton for a program with dynamic file name. Again, I will take data file as internal file name, assign to, and now I use the dynamic keyword and just use a variable called var file name, and this one I have to define in the working storage section. Just copy it in here, so my usual data set now here actually has two names, and yeah, var file name. So this is pretty much like we had it before. So let's write a program with that. First, we want to read the file name. And then we want to write something to the file that we just declared. Just copy it in. So I read first name, last name, and age for this record. I actually don't need this counter here. Let's get rid of it. I write it to the file, and I close the file. And that's that. Okay, so we just write one entry as a proof of concept. Something is bad. File control. Enter file name. How would we call that file? My dynamic file.dat. That's it. So yeah, this file exists now and has the data we entered. Maybe to prove to you, let's do another file, second dynamic file .dat, and to prove to you this file does not exist. So and now this file exists, and it has the data we just entered. So you see, we can use dynamic file names. We can even have the user input these file names and then dynamically write to a file. That's it. So we've gone through quite a bit of COBOL in this and the previous videos, and this actually concludes the main overview of the COBOL language from my point of view. Thanks for watching all these videos. Don't forget to like this video and subscribe to my channel, and I will look into maybe creating a bit of a more involved project for COBOL to combine all the things we've learned in this course together into a more interesting, non-trivial project, and let's see how we do something like that in COBOL. Thanks again, and see you in my next video.